The images from Hubble are legendary. They changed the way we understand our universe. And after 30 plus years, billions of dollars in cost overruns, and countless material and design breakthroughs, Hubble's successor is about to launch into space. And the stakes are high.
It's kind of a cliche to say that it's going to change the course of astronomy, but it might very well do that because it's such a leap in capability.
NASA is folding, yes, folding, a $10 billion space telescope into a rocket, blasting it into space, and counting on 50 precise steps happening in exactly the right order over the course of a month, while in outer space, so they can plant it 1 million miles away and pray it works as designed.
Once we leave the planet, it's on its own. We're going to learn some things about how galaxies were formed and how the Earth came into being. It's certainly going to shape our textbooks going forward.
The James Webb Space Telescope will allow us to see what happened 13 billion years ago, back to when the very first stars and galaxies were being born. We might be able to find habitable exoplanets, or planets that have similar conditions to Earth.
That would just be so astounding if we could do that.
But there are a lot of ifs between here and there, because making something so powerful is a precarious business. For one, rocket launches are never exactly routine.
Houston, we've had a problem.
Then, once it's actually in space, the drama really ratchets up.
There are a lot of precise things on Webb, and a lot of things need to happen precisely.
For example, powerful telescopes require big mirrors.
The larger the mirror, the fainter the thing you can see. The larger the mirror, the finer the detail you can see.
The Webb mirror is 21 feet across, which is 6 times the size of Hubble's.
The mirror has to fold up for launch. It's too big to fit inside the rocket otherwise.
To get 18 segments to act as one seamless giant mirror, the motors controlling each segment have to be adjustable down to millionths of an inch.
It's going to take a couple of months to get the mirror perfectly lined up.
So after blasting it into space, they've got to unfold not just the mirror, but a sun shield, the likes of which we've never seen before.
Just under the mirror is that tennis court size sun shield, 5 different layers, new technology for those membranes. That's the thickness of a hair on your head. And those 5 layers give us an SPF of over 1 million.
In order to see deep into space, the telescope has to be extremely cold, hence the sun shield. That's also why they're sending it 1 million miles away. There are special points in space called Lagrange points, where the gravity from the nearby stars, planets, and moons essentially cancel each other out, meaning it requires very little fuel to stay in place. And at the Lagrange point they're planting Webb,
the sun, the Earth, and the moon are always in the same direction away from Webb, so we can always keep their heat out of the telescope.
The things they had to engineer or invent or solve to make Webb a reality are staggering. That's part of why it's taken so long and so much money to get this thing into space.
Webb is about the same scale project in terms of dollars and people as building the Great Pyramid in Egypt. And that gives you kind of a sense that Webb is on a scale that's kind of a cultural undertaking and not just something for astronomers.
Thanks for watching our YouTube channel. Follow today's top stories and breaking news by downloading the NBC News app.